In this video, we're going to implement a recycler view on our event screen. Now, recycler views are a little bit complicated, and there's a separate video where I just go over an overview of all the components. I'll refer to that occasionally in this video, but if you haven't already done so, I strongly recommend that you watch that video first. It's called Simple Explanation of Recycler View in Android. This video is going to be a hands-on implementation of that. So a few things we're going to do in this video. We're going to create a row layout, we're going to create an adapter and a view holder, and we're going to add a recycler view to our existing event screen right here. One little sidebar on that is that a recycler view wants to deal with its own swipe events, and that can come into conflict with the swipe left, swipe right that we already have on our activity. So as part of this, I'm also going to add a button eventually to do that swipe left, swipe right as well. Nonetheless, let's jump right in. First, remember that the row layout is going to be repeated in the recycler view, one for each item in a list. In our case, we're going to show two things in the row layout: a picture that we take, if available. If not, we'll just put in a dummy image. And then also a text representation of this event that we have created. Let's start by making that row layout. We create the row layout right in the same directory where we create all the other layouts that our user sees. So res and then layout, and then right click and then choose new. Scroll down to XML and then choose layout XML file. And we'll call this one row layout. Could probably name it something a little better than that, but we'll just go with row layout. This is going to be very simple compared to the other layouts that we create. We don't need to worry about all kinds of different widgets because it's really just going to be two things going on here. So linear layout is fine. I'm going to change layout height to wrap content though. We can either do that here in the text view or we can do it in design view. Reason being, match parent would mean take up all the available space, where wrap content says only take up as much height as I actually need to display the components that I want to show. Because we're likely going to be showing multiple of these layouts in one recycler view, we want to keep it nice and concise as best as we can. Now back to our UI screen, we want to add an image view. We can always type it in up at the top if we don't see it, or just search for it down here in our palette. Let's go ahead and drag it and drop it right under our linear layout. It's going to ask us for a default image, which is something we'll show if we don't put an actual picture in there. And that will be the case several times because an image is not required for our event. It's optional. So I'm just going to kind of put the space filler in there just like so. And let's also give it a name that we will remember later. Let's call it IMG Event Thumbnail. One more, we also want to show a text view. So the text view is going to be a textual description of the event. Just like before, let's drop it underneath our linear layout. And let's give this also a helpful name. We'll call this one LBL Event Info, like so. Now, if we zoom, it's kind of hard to see until we zoom up, but if you zoom up here, what you see is we have the image placeholder over here, and then we have the text view over here. Let's go ahead and make that, let's empty out that text view text. Don't need that. It's going to fill in with our event anyway. So at this point, our row layout is done. Let's move on to the next step. Let's go ahead and create a recycler view and put it into our existing events fragment. We'll put it right down in this area here. After that, we'll move on to the view holder, which is going to populate the row layout with each of the objects from our list, and the adapter, which creates the view holder. But for now, the recycler view. So I'm in the event fragment, and you see we have the recycler view here, but one thing to note is that we actually have to download it. So it gives us a warning. I read through this warning earlier and I found I was able to go ahead and use it in my case. Pause and take a look at this just in case you run into conflicts with your own project, but that's one of the tricks with Android, is that a lot of these libraries have dependencies on others. So it's going to download the library and then rebuild Gradle. So far things look good because it says the Gradle build finished, so I'm going to grab the recycler view and simply drop it into the screen. This is a constraint layout, so we'll have to get a little bit tricky with these constraints. Here's where either zooming up or going to the text view under the covers is sometimes helpful. We'll get a couple distractions out of our way here. Now I'm going to take this constraint, and it's really delicate here because we need to add it to the bottom of the linear layout. You see, fortunately it gives me a choice because it sees we have a whole bunch of constraints and anchors all together. So boom, like that. Let's take the left, anchor it left. Let's take the right, anchor it right. And even though it looks like we're not really doing a whole lot, you notice when that clear circle fills in and becomes blue and indicates that our anchor has been anchored. So a little tricky. There we go. Got that one. The trick here is that we just happen to be right on top of where we want to anchor. So nonetheless, all of them are blue. Let's double check in the text view. And frankly, probably best just do this all in text view if you're more comfortable with that. So we see we're anchoring to the bottom of the parent, which is our layout entirely. And then the top constraint is right below the linear layout. The linear layout is our button bar here. Layout width and height, probably going to change this guy to match constraint. I'm a bit nervous about having a fixed position in there, but nonetheless, finally we have our recycler view set up. Let's just give it a reasonable name. Let's say RCY events, something like that. Now we've created the row layout. We've created the recycler view. Let's move on to the view holder, and after that, the adapter. Event Fragment is the class that supports this layout that we're looking at right now. We see that it extends from Diary Fragment. Normally what you'll do is you'll create the adapter and the view holder right here in this event fragment, but I just happen to know that I'm going to want to reuse these in some other fragments as well. So what I'm going to do is put them up in Diary Fragment and simply inherit them into event fragment, which is perfectly legal and a nice efficient way to do things without repeating ourselves. So I click up to Diary Fragment. Let's go ahead and go into distraction-free mode because I know I'm going to be spending a lot of time here. Notice this is also an open class, which means it can be inherited. Let's scroll down towards the bottom and give ourselves a bit of room here. And let's say inner class event view holder item view of type view. Now, what is that? That's actually the layout that we're dealing with. That little row layout that we made earlier, it's going to be represented into this ItemView variable that we see here. And we simply need to extend from RecyclerView .view holder and pass in ItemView. Now, a couple notes. First of all, we're going to get a note here that we need to import RecyclerView. If you don't see that, or you don't see the package that I just selected, make sure that you have indeed downloaded the RecyclerView and it's in your build.gradle. That was that automatic step that happened a moment ago. Secondly, what's going on here where we have ItemView over here? Well, this is the constructor for the class that we are now creating. And in that constructor, we're receiving a parameter variable called ItemView. We're extending this view holder class, which is essentially a class that belongs to RecyclerView. That constructor also requires a view argument, so we're simply taking this and we're passing it up to the super constructor. That's all that's going on there. Open curly, close curly. Let's declare a couple of items that we're going to need to access in a moment. So private var img event thumbnail of type ImageView equals ItemView. I remember ItemView. I was just talking about that. That's the guy up here. So that's that row layout that we made earlier. ItemView.findView by ID. And we pass into this, let's see, we'll not worry about the generics because we have the type defined. We pass into this r.id.img event thumbnail, just like so. Okay, let me take care of this red line because it makes me nervous. Go ahead and add that. And let me explain what's going on here. FineView by ID allows us to go out to a layout and find a specific component from that layout. So far we haven't had to do that because we've been using Android synthetics which import those components automatically. In other words, if I go back to something like Event Fragment, you can see that I'm referring to components on the screen. Let's find one here, EDT event type, date and type. It's just able to find those automatically because it has this Kotlin synthetic for us, which grabs those and pulls those in. That is a huge improvement over the old days. In the old days, we had to do one of these FineView by ID for every single component on the layout that we wanted to use. In this case, we do want to do the FineView by ID because remember, this is a specific layout. It's the row layout that we just created. You might remember on that row layout, we had this image where we kind of put a dummy image in there, an image view with a dummy image. We're simply getting access to that and we're storing it into this variable here. That's from the individual row layout that's going to be populated inside of our recycler view. And that's going to be right next to a whole bunch of other row layouts where each row layout represents one item in our collection. So we have the image thumbnail. Remember, we also had a label. The label is what's going to show the event text. Let's go ahead and grab that. Private var LBL Event info of type text view. Remember, that was the text view we added. Equals ItemView dot FineView by ID. Again, you see, whoops, fine. And again, not worry about the generic here because we've already indicated the type. r.id.lbl event info. And we will go ahead and import that text view. Import just like so. Once again, just want to kind of draw a couple things together here. Row layout. ItemView represents this guy here, and we've just pulled off this IMG event thumbnail and this LBL event info. We're just getting access to those two UI components. With that said, let's return back to our diary fragment where we were just working. We have a function in ItemView holder called update event. Or we'll make one, actually. Fun update event. And then we'll say variable name event of type event. Now, what is event? That's a DTO we created just in a prior video. Go ahead and import that. And event. And again, just to remember what that is, it's a one-line Kotlin data class that represents one of the events that can happen to our specimen. We're watering it, we're fertilizing it, we're pruning it, we're splitting it, we're taking fruit from it. Any of these things could be event. It's a data class. Just think about that. It's a data class. It's a DTO. So what we're doing is this function will get called. I'll put some comments to this effect. This function will get called once for each item in the collection that we want to show in our recycler view. And the job of this function is to paint a single row of the recycler view with this event data class. Make that very specific. In hindsight, I probably should have named it something more specific than event, just because that's a word we hear a lot in programming. Okay, nonetheless, LBL event info dot text. So that's the text box that the user is going to see on the recycler view. This one's easy. Event dot toString. So just give me a string representation of that event. As a matter of fact, let's go ahead and go into our event and let's give that a toString function. We know in Kotlin it gives us a default toString function, and the toString function says if I need to take this data class and represent it as a string, what am I going to put in that string? We can override the default toString, just like so, and we can give it whatever we want to be a textual representation of this object. If I look up above, type is going to be water, fertilize, prune, fruit, and quantity units is going to be how much, and then we have description. I'm thinking what I want to return here is, let's say type, and then we'll say quantity, and then we'll say units, and then we'll say description. Note that I'm using a Kotlin shortcut here, which is where we put double quotes, and then we can refer to variables directly with the $sign indicator, and Kotlin simply inserts those variables in line in that location. Back in the Java days, we had to do all kinds of concatenation with a plus operator. With Kotlin, this is a lot faster. We simply put it in like so, and you notice I put a space between each of these attributes. That makes it a little bit easier to read. Okay, now once again, where's this going to go? We'll go to our friend RowLayout. It's going to go in this text box over here. We will see it will dynamically change width a little bit. So we are stuffing a whole lot of information in there, but that's what the user's actually going to see. Okay, now we need to handle that image part, and this is where things get a little trickier. So let's go back to our diary fragment, and let's say if event local photo URI. If you remember from our previous video, local photo URI is the path to this image on the user's local device. We're simplifying things here, and we're assuming that the images are on the user's device. We could have it stored up in the cloud somewhere and cache it down, but let's just keep things simple right now. So first of all, we only want to populate the image if this is not null. So we use the exclamation equal to say make sure it's not null. Now there's a weird thing in Kotlin. Normally if you invoke a function on a variable that contains null, Kotlin just returns null. Not so for toString. ToString, if you invoke that on a null reference, you will get the word null in quotes. So we want to cover for that as well. So let's say and &, event.local photo URI is not equal to double quote null, like so. No matter which one of those happens, as long as we pass this if test, we have an image URI. Okay, so I'm going to say image decoder dot create source, and what this does is it takes a URI and it essentially helps to create an image by reading the file that's at that URI. We have to do a little trickiness with it though. First of all, let's go ahead and import. Okay, now create source takes two arguments. One is a content resolver, and we can get that from our activity, which we just kind of have we have a variable that represents our activity. Let's assert that it's not going to be null with the two exclamations. It just says this is theoretically a nullable type, but in this case we know it's not null. And then we can refer directly to content resolver. After that, let's say URI.parse, because remember, local photo URI, that variable, is actually a string. So we call URI.parse to convert it from a string to an actual URI object. And we'll say event.localPhotoURI, just like so. So take that and let's save that in a variable, a final variable called source. And then that source variable we pass on to image decoder one more time. Image decoder dot decode bitmap, and then we'll pass in source, and we'll save that to val bitmap. Now, by the way, I went through this several videos ago when we were initially looking at how to capture an image from the image gallery. So if you want a deeper description, I'll point you back to that video, but I'm assuming you've already seen that, and that's why I'm giving it kind of a quick description here. Finally, let's take the image and put it in the thumbnail of the row layout. Okay, img event thumbnail, note the variable we declared on line 94. .set image bitmap, and then we pass in our bitmap just like so. Wow, take a look at that. And that's it for our view holder. Now on to the adapter, which is going to create the view holder. And the adapter, in a final step, when that's done, we're going to link that together with our RecyclerView in our event fragment. Back to the superclass diary fragment, inner class events adapter. And we'll say val events list event. What is that? That's the collection we want to show through our RecyclerView. And then we'll say val item layout int. What's that? That's that row layout that we're using to show each of the individual events. It's an int because we're using a constant to refer to it. Then we're going to say we extend from RecyclerView.adapter. And here we have to pass in a generic, and it's kind of a funny generic. We have to pass in the view holder that this adapter is going to use to show each of those events. That view holder is this inner class we created right down here on line 95. So for that, we'll simply say diary fragment.event view holder, open and close paren, open curly, and close curly. Okay, we have a red line. We know we want to stop and take care of that first. Let's go ahead and say implement members. What that means is that we are extending from the adapter class of RecyclerView. That has several abstract functions, which means that if we subclass that adapter, we either have to implement those members or we have to be subclassed again with something else that will implement those members. Let's go ahead and implement these members. We'll select all. And okay, copy the Java doc if we want, not necessary, but we can. The reason why we have to implement these member functions is because the RecyclerView adapter doesn't know what we want to do with them. We have to specify that ourselves. So let's start just from the top with onCreateViewHolder. So we'll say layout inflator dot from parent dot context dot inflate item layout parent, and then false. Okay, what's going on here? What we're doing is we are inflating one of those individual row layouts. And we're going to save that into something called view. So val view is going to be our variable. And then we're simply going to pass that to our event view holder. Return event view holder view. Now what do I mean by that? We're going to pass that to our event view holder. Let's go down and look at our event view holder again. Remember how that accepts this view here? We're simply taking that row layout, we're passing it to this event view holder, that's passing it to its superclass, and then remember, that's our row layout, that individual row. From that, we're getting our image, our little image view that we have, and our text view as well. And then we're using that, we're taking our event DTO, we're populating the image from that event DTO into the thumbnail, we're populating the text from the toString into this event info here. So again, I know it's kind of follow the bouncing ball, but the job of the adapter is to create that view holder, to give it a layout, and then the view holder itself will populate that layout. Okay, good news on the next one though. Get item count is really easy because this adapter is taking this list of events and putting it into our recycler view. Get item count is just how long is that list of events? So let's see, our variable is called events. This is easy. We simply say return events size. That's how big it is. Okay, one more to go. On bind view holder, for this one, we say val event equals events.get position. Okay, what's going on there? Well, we're saying that we have a collection of events. This is going through and it's populating the recycler view with each of those events. It's saying I'm currently at this position, so give me the object that I should use to populate the recycler view at this position. For that, we go to our events collection. We pass it this position number. Events collection, think of that like an array list or a list. If this is position 3, it's simply going to navigate down to position 3, find that event data class, the object of that data class, and pass it off to our view holder. The pass it off to our view holder is the part that comes next. Holder.update event. What's holder.update event? Well, gosh, look at that. That's the function we made just a little bit ago. So here again, I know this is bouncing around a bit, but it's kind of tricky to have a good order to show these in because we can't make the view holder and update this event function until we have the update event function. We can't do that until we have a view holder. So the order of making this is a little bit goofy, and if it's your first time doing a recycler view, you might find that you're doing it in a kind of funny order. You might start with the adapter and then realize you need the view holder and so on and so forth. This is the way I've found to do it that makes the most sense. All that being said, we've taken care of a lot of things here and a lot of things here, but now we need to take the adapter and we need to link it up to our recycler view. So one step to go. I navigate from diary fragment back to the event fragment, which is the subclass of diary fragment that's going to handle all this for us. And in the onActivityCreated function, I'm going to say wire up our recycler view. So we'll say RCY events.hasFixedSize. These are some kind of boilerplate things, but things that I found just to make the recycler view fit properly and act appropriately. So RCY hasFixedSize, RCY events dot item animator, or let's say layout manager, equals linear layout manager, and then we need to pass that a context. So context we have locally. Linear layout manager we can import just like so. RCY events dot item animator equals default item animator, open and close paren to indicate we're creating a new object. And then finally, RCY events dot adapter equals events adapter. Does that sound familiar? I hope it does, because it is the class, the inner class that we just created just a few moments ago. So we know we need to pass this two things. Number one, the collection that we want to show. So let's say viewModel.specimen.events. And why is that the collection we want to show? We'll take a look down at the save event function right below and take a look viewModel.specimen.events.addEvent. Anytime we hit the save button to create a new event, we're putting it onto this viewModel.specimen.event. The next thing is we need to give it the layout that we want to show for each one of these events, which is the very first thing we did. We created that r.layout.rowLayout. Aha, okay. So just take a note here, see we're in event fragment. Watch what happens when I click on this events adapter. Does this look familiar? Hopefully a little bit familiar. The class that we just created. So the event fragment calls the event adapter calls the event view holder, and all of this marries together to show us everything in our recycler view. Let's go back down to save event, because anytime we create a new event, we want the recycler view to update automatically. And we can do that with a kind of a neat function here. We say rcy events.adapter. Let's go ahead and put the nullability indicator there, the question mark, and then say notify dataset changed. And what that does is it just tells the recycler view, hey, you might have new data. Now I started the emulator and I got us a head start here. I went ahead and entered a brand new specimen, and I came to the event screen and I added one item with a photo. So here's our photo thumbnail, and then the event that I already added was water 1 gallon with the description it was dry. If you take a look, and I know it's kind of faint in a small font, we can probably bump that up a little bit. But if you take a look here, you can see that sure enough that text appears here. We might also want to constrain that image, make it a little bit smaller. All in aesthetics, but nonetheless we can see things are working. Now, here's what we want to see is what happens if I had a new event. Let's say fertilizer. And let's say 1 cup. We'll give it an event day of March 25th, 2020. And we'll say high nitrogen fertilizer. Probably misspelled a couple things there, but not worried too much about it. Let's go ahead and snap a photo. Maybe we're taking a picture of us fertilizing the plant. So I'll do a little spin here so we can get a little different view of the photo. And now let's come back and choose Save. When I save, I not just want to make sure that the event's saved, but I also want to see the recycler view update. So I hit Save, come back, and we see it's going to walk us through just what we saw before. We create a new event object. We populate that event object. We do have a photo, so you notice that it is going to populate the photo with our photo URI. Have a little URI right there. And choose F8. And now here's the tricky part. I'm going to choose F9, and it's going to notify the recycler view that the data have changed. So we come back, and we notice that it cleared out the user interface as I hoped it would. Now notice as I scroll up, oh, look at that. Look at that. You see our recycler view has updated. We have a new photo. We have a new event. Now this is a lot of fun. So let's do one more, but this time let's do it without a photo. So let's say prune. Quantity 12 units branches. Event date, we'll say March 30th, 2020. We say prune back some dead branches. I know I've mistyped a little bit there, not to worry about it. We're going to skip the photo, go straight to the save. I hit the save. We've seen this before. We're going to create a new event object. We're going to populate that event object. This time we're going to skip over the photo because there is no photo URI. And I choose F9 and choose F9 again. It updates our collection. We come back and let's take a look at the recycler view. So we have the first item that we had when I paused the video. We have the next item that we did together, and we scroll on down and we see our final item with that little placeholder image there. We see prune 12.0 branches, prune back some dead branches. Once again, I know a tiny font. We can improve that a little bit, probably a good idea for usability and accessibility sake. But what we do see is that a recycler view is implemented, and we know that as recycler views work, even if we had 1,000 events, it would not have to create 1,000 image views and 1,000 text views. It only has to create just enough to be shown on our physical screen, plus or minus 1 or 2 for the recycler view layouts that are coming up as I scroll. So that's a look at our recycler view implementation. I hope this is helpful, and I look forward to reading your comments. Thank you.